Okay, so we will be starting with this transmission system. Okay, and this photograph is possibly taken from slides here. I do not remember actually exactly from where it is taken, but uh, what we are doing in our this particular transmission system, if you see, we have the engine with us. Okay, where the power is generated and through crankshaft it will be transferred ahead. Okay, so after the engine you have got the flywheel. Okay, so E stands for engine, F stands for flywheel. Flywheel to maintain that energy level. So once we are passing to the flywheel, then we will have the clutch system. C stands for clutch, and that clutch system is shown over here. Okay, this down part, this one is the clutch system. Okay, so this clutch system is what its basic purpose is: to engage and disengage this engine power to our transmission system. Okay, and after that we have got the transmission system, and then from transmission system the power will flow to wheels. Okay, so these are the wheels, and here what we will have, here we will have a system that is called as a differential. Okay, so the transmission system and this differential, they are heavily dependent on the gear systems. Okay, the gear sets, the concept which we have learned in previous classes. So this is a wide application and a great application of the gear system. So what is happening here, if you see, the actual procedure is what? I mean, in a general, if you see, the engine is always running, okay? Because you cannot switch on and switch off engine always. So engine will be always in the running condition. If you are driving and you want to stop the car, then what will happen? You want to stop basically these wheels, okay? If you are willing to stop the wheels, it means there should not be any power transmission through this particular axle, this transmission shaft or main shaft to the wheels. So for that purpose we have got the clutch. Now you see here the clutch box is given here. So what happens, we have got the clutch pedal, it is coming to this particular position. Okay. Okay, so this is our clutch shifter, actually clutch pedal. So it will basically push. If you see, we have got two components, and because of this pushing, this will be engaged or disengaged. So actually because of pushing, the clutch friction clutches, they will be disengaged, and so they will not be in a condition to transmit the power. And when you are running this transmission box, during that time this clutch will be completely engaged. All the friction components, they will be engaged together, and through friction they will be transmitting to the power. So you can say that this first wheel that is in the blue color, this is connected to the clutch box. Okay, connected to the crankshaft, you can say. Now the thing is that we want multiple transmission ratios. You want higher torque sometime. If you are going upward on a hill, you require high amount of torque. If you are running on a smooth road, you require less amount of torque but higher amount of speed. So basically this transmission system, it will help you in doing that one. So directly you cannot transmit the power. If you see, in the straight line you cannot transmit the power. Because if you are transmitting, there will be only one particular speed, and that will be the engine speed. The speed on which, the RPM on which the engine is running, that speed only you will be able to transmit. So we are putting a counter shaft over here. The red color, this particular setup is the counter shaft actually. Okay. And this first gear which is connected to this clutch gear, this first gear, this is called as the counter gear. So they will be always in contact. Okay. And then this shaft will keep on running. This shaft is always running. This counter shaft, the red shaft, it will be always running. And then it will transmit the power to the main shaft. Now, if you see, this is a reverted compound gear train. Reverted why? This is our input shaft. Then we are coming to some other place, the counter shaft, and then again the power is transmitted to the main shaft. And you say there are multiple gears on this main shaft. So this is basically the reverted compound gear train. Okay. So we'll be talking about this one because this is the constant mess. So I will talk about this one later on. We'll start with, of course, the basic one, that is the manual, I mean the initial gearboxes, whatever we have. So we'll start from there. So if you see in our transmission system, we are using either the hydraulic system or the mechanical system. Definitely the mechanical systems are older one. They contain a clutch, a gearbox, and axle. Okay, I mean this is the part, of course, you have to have this axle anywhere. The clutch and gearbox, I will say that this is the part of our mechanical system. And still the manual transmissions, whatever we have, when you are shifting the gears, they will contain this clutch and gearbox system. Okay. Now, as far as this gearbox is concerned, of course, we will be talking a lot today about this gearbox system. The hydraulic system means you have got the properties of the fluid. Okay. And you will be utilizing those properties to transmit the torque. You remember here we are transmitting the torque as well. So although here it is written as torque converter, this is one, but there are automatic transmissions also. Okay. The torque converter, it is heavily using the hydraulic one, and actually this is a you can say a good invention as far as the automatic vehicles are automotive transmission system is concerned. Okay, so just we'll be talking a little bit about these torque converters and automatic transmissions also. Okay, but our emphasis is what? On the clutch, gearbox, and the mechanical system. So the initial gear system, possibly this may be the first gear system which we have, that is called as crash box transmission. Okay, in the manual transmission system. So again, if you see this is the input shaft from the clutch. You are coming to the input shaft. So this is clutch gear, I will say. Okay, and then you are coming to the counter gear over here on the counter shaft. Now, if you see, there are 1, 2, 3. Okay, 1, 2, and this last one actually, if you see this last one, my pointer is visible to you all or not?
Yes, sir.
Okay.
Yes, sir.
So this last one actually, this one is the reverse gear. In all the gear, this manual transmission, the last one will be the reverse gear. And what happens, you know, that if there are I mean you have to make the reversal, what you are doing, you are adding one idler. Okay, because in other systems the one gear is rotating if clockwise, another will rotate opposite to that one. Okay, so that is the system. So the idler gear, it will be helping you to change the direction. So in the reverse gear system, that is what we have, the idler. In other one, we have the gear sets. Gear set means 1 and 2. One is input gear, another is output gear. So definitely the clutch gear, that is N2 equal to 14. I mean N stands for T, number of teeth. Okay. So this clutch gear and this counter gear T3 equal to 31. they are always in constant mesh. Okay, you are not going to change their mesh. Whether you consider this crash box, this is the old transmission system. Now we are not using this particular transmission system, or you consider the newer one, they will be always in contact. So the last gear I said that of course this is our reverse gear. So during the reverse gear engagement, there will be no other, I mean, engagement between the gears. So what will happen? The power will come to the counter gear, and since this shaft is rotating, it will come to this gear T6 equal to 14. And then you have got the idler. So this idler will be brought in connection to this T9 equal to 27. Okay. So the direction will be reversed. That is fine. But generally we do not face problem in this one. Why? Because when you are applying the reverse gear, your vehicle will be static. I mean, you are not moving. It's not that you are moving and suddenly you apply the reverse gear. That is not going to happen. So actually this particular gear does not pose any problem. But let us see in this crash box transmission what used to happen. This particular one, the counter shaft, this is always in motion. Why? Because this is attached to this clutch gear. Now if you see, there are only one and two gears. Okay, if you see here, there are one, that is T4 equal to 25, and then another one is T5, that is equal to 81, 80 number. Okay, so what we have, let me say that you want to apply the first gear. First gear is what? Highest amount of torque. The speed will be lower. So if that is the case, then the output value will be high, the T9 equal to 27. So this T9, when you are going for reversal, it will be connected to this T6 and T7 system. And when you are going for first gear, this T9 will be connected to T5. So if you see here, you will observe the spline. Okay, on the output shaft there are splines. So basically this gear can move along the axis, and the gear shifters, they will be connected over here. If you see, there is, I mean, a slot kind of thing. So the gear shifters will be connected over here. So that gear shifter will push this particular gear, I mean, either to the right or to the left. So when you are engaging the first gear, it will be shifted to the left, T9 will be shifted to the left, and it will be connected to T5. Now the fact is that T5 is in the running condition. Okay, and suddenly you are getting the engagement, and definitely the output shaft also. Suppose you are in the motion and you are lowering the gear to 1, then definitely this will be in the motion. Okay, so during the motion itself, there will be the engagement, and definitely that engagement cannot be a smooth engagement. It will have the noise, it will have the damage also possibility. Okay, so that is the issue with this one. That is why we used to call this one as crash box. There will be always impact. As much you change the gears, there will be always some impact among the teeth gears. Now, so this one is the first gear. Okay, first and reverse. Now you come to T4 equal to 25. This is our second gear actually. If you see, the number of teeth is higher, 25, and then you have got T8, number of teeth lower, 20. It means you are going to transmit lower amount of torque, higher amount of speed. So this is our second gear. So when you want to apply the second gear, what will happen? The gear shifter, it will push this T2, this T8 to the right, because you cannot change the position of T4. So this will be shifted to the right. And when you are shifting it to the right, this T8 will be in contact with T4. And then the motion will be transmitted. That will be called as second gear. Okay. And the highest gear here is what? Third gear. Although you may say that, sir, third gear is not visible. So the fact is that one of the gears in these manual systems will be always what? That you directly transmit the power from input to output shaft. So what will happen if you see this T2 equal to 14? This is the clutch gear, and if you see, you'll observe some other, I mean, spline kind of thing over here. So what will happen? This T8, it will be shifted to left side, to this side, towards T2. So this will be engaged with the clutch gear directly. This one. All other gears are disengaged. This T8 will be directly engaged over here. So actually this is a shaft to shaft connection. You can say that there is a coupling, okay? Coupling between the shaft. So when you are able to create that coupling, whatever is the input speed, it will be transmitted to the output speed. So actually this is a 3 gear. Whatever system is shown, it is 3 speed manual transmission system. Gear number 1 is coming from T5, gear number 2 is coming from T4, and gear number 3 is coming from direct transmission from input to output shaft. Now the fact is that these gears, they used to have the heavy noise. Along with that, there were the gear failures, the gearbox failures. I mean the crashing of the gearboxes. So these systems were changed, okay? And they were changed to which kind of system? The constant mesh transmission system. Okay, the constant mesh transmission system. So the first slide, whatever I have shown you, this is the constant mesh transmission system. This is the colored one. So I will try to explain over here. Okay, so in the constant mesh transmission system, what is happening? Unlike the crash box transmission, I mean the original one, we have got the constant contact between the gears. Each and every gear is fixed. I mean, they will be always in contact. If you see, of course, the clutch gear and counter gear, they will be always in contact. If you see here, this is the smallest one and this is the largest one. So definitely this is going to be what? The first gear in our case. Okay. So this first gear is here in contact with a particular gear. So I mean, you have got a fixed gear set. In the crash box, you do not have a fixed gear set. One input gear is connecting to 2 output gears. Okay, so here what we have got, a fixed gear set. This smaller one is fixed with this one. This second one is fixed with this one. Third one is fixed. I mean, every gear is fixed. What else is there? That definitely there will be, since this is the input gear, the red color one is the input one, the counter gear. This will be always in rotation. So it means what? These gears, the blue color gears on the output shaft, they will be also always in motion. But the fact is that these gears are blue gears are on bearings. So when they are on bearings, they will keep on rotating, okay, based on the speed. But they will not affect the motion of the main shaft because we are not engaging them. Okay, so here we have got now the dog clutches. Okay, we have got the gear selector mechanism. You apply gear 1, 2, 3, 4, whatever is there. So that movement will create a movement in the dog clutch system. Okay, suppose you are interested in engaging the first gear. So what will happen? This dog clutch, you remember that this counter shaft and all the blue gears, I mean all the gears on the main shaft, they are rotating. They are always in constant mesh. That is why we call them constant mesh. And then in this constant mesh also later on we have something else. Okay, just I will tell you. So what happens? This dog clutch, it will move in a spline. This dog clutch is actually splined one. Okay, so this will move in a spline and then it will engage. If you see, there will be teeth. So this dog clutch will engage the gear and then the power will be transmitted to the main shaft. Now again, in this constant mesh also, this was the issue because you cannot have a smooth transmission. When the dog clutch is going to engage the gear, you cannot have the smooth transmission. But still it was better than the crash box transmission. Okay. So later on in this particular system also, we have the improvements. And what was that improvement? To synchronize the attachment of the gear with the dog clutch. Okay, so in between this dog clutch and this blue color gear, there is something else, which you can say that is acting as a synchronizer. So it will synchronize the motion. Okay, and that connection will be smooth. So nowadays we have the synchromesh. Okay, synchronized one. Now let me just explain you. Okay, so this dog clutch, when it is moving to left side, it will connect gear 1. When it is moving to the right side, it will connect gear 2. Similarly, this middle one, dog clutch, it will create third and fourth gear. And this one, if you see, it will connect gear number 5. And what else? Gear number, I mean this reverse gear. This is the reverse. Yellow color is the idler. So this is the reverse gear. Okay, so this is our constant mesh. Now the synchronous one that is shown in the picture, maybe few things will be visible. There are multiple, I mean, components, they are involved here. Okay, the clutch gear is there, this is our counter gear, that is fine. Okay, and what is shown, the first gear is shown over here. First gear means on the counter gear you have got the smallest one, and on the main shaft you have got the largest gear. Okay, so that will be the first gear definitely. So here this synchronizer, of course this is a kind of conical arrangement with teeth. Okay, I will suggest you to uh, go through some videos where you may find out that teeth engagement. Okay, so and that teeth is, I mean, kind of one sided slot. Okay, so it will be easy to slip in. Okay, when you are moving this synchronous, this conical part inside the gear, it will be easy actually to slip in. Okay, and it can easily actually engage. Okay, so I mean that mechanism is there. So this synchronizer along with dog clutch will be pushed inside the gear, where you have got I mean a friction lining kind of thing, and there will be the teeth, one sided teeth. So this synchronizer will be connecting to that one, and that teeth is always connected to the gear. Okay, so that way you will be able to transmit the smooth motion. So this constant mesh I will say that this synchromesh, synchronized one, this is nowadays in use in our manual transmission systems. Okay, the gears will be always the helical because they will create a less amount of noise. As far as the idle reverse gear is concerned, you all know that. Okay, it you can move the create the motion, no issue. I mean lateral movement is possible because the vehicle will be in idle position. For other gears, the synchronizer will be helping you. So this constant mesh transmission with the synchronizer. So this is the first gear. Now you see actually, just I will show you the motion transmission. If you see, it is shown. If you see, this is the arrow, and how it is coming, it is coming to the counter gear, and then if you see, you will observe this motion. Okay, it is coming to the gear, and again from the gear, if you see, it is directly not going to the gear, although the gears are in always in contact, but it is not directly going to the gear. Rather, what it is saying, that it will go to the synchronizer. Okay, these gears are always in contact, but the fact is that the gear is directly not transmitting the motion to the main shaft because the gear is on bearing. The first gear, the second gear, third gear, every gear on the main shaft is on bearing. So it is free to rotate. It is not going to affect the motion of this main shaft. And that is why the power flow is shown through the synchronizer. Because that synchronizer, it will connect the main shaft to this particular gear. And since this gear is always in motion, this will be transmitted to the synchronizer, and then it will be connected, I mean synchronizer, and then it will be transferred to the main shaft. Okay, so this is our first gear. Then definitely there will be the second gear. So this will be your second gear possibly. The third gear and the fourth gear will be, of course, what? The direct transmission. So this is our third speed here. It is shown. Okay, it is coming to the clutch gear, to the counter gear, and then this is our third gear. This is our first second. Okay, first gear, second gear, this is our third gear, this is our reverse gear. I mean, based on the gear size, you can identify which one is the first gear, which one is the second gear. Okay. So this third gear, it is transmitting through this synchronizer. If you see here, you have got the synchronizer, and this arrow is clearly shown, okay, through the synchronizer. Anyway, the third gear, they are always in contact. Just I have drawn the vertical line if you see. So the third gear, they will be always in contact, but the power flow is shown through the synchronizer because the gear is on a bearing. It is free to rotate. So when the synchronizer is connected, this gear will transmit a torque through synchronizer to whom? To the main shaft. And when you are going for the fourth gear, what will happen? This synchronizer, this will be shifted towards left, and it will be directly attached to the input gear. So basically, in that situation, the power transmission will be direct, straight line, okay, on this axis, because the synchronizer is acting as a coupling between the input shaft. You have got the input shaft and you have got the output shaft. So power is in, power is out, and here you have got a coupling, and this coupling is what? This synchronizer. So this coupling will connect these two shaft, and it will act as what? The fourth gear. Okay. So in all these manual transmissions, that one gear, of course, this is a cost cutting and an effective way. You are able to transmit the higher amount of power. Now suppose you are taking 5 gears. So actually generally in 5 or 6 gears also, this fourth gear is generally the direct transmission. Please remember. Generally, you will observe that even in 6 gear transmission, this fourth gear is generally the direct one. I mean, from the input directly we are able to transmit the power to the output gear. So the fifth and sixth gear, they will be what? They will be creating additional speed ratio, higher speed ratio than the engine. Okay, input. So if input RPM is 1000, the fifth and sixth gear are capable of creating more amount of RPM. Okay, and fourth one will be generally the straight line. I mean, the input RPM equal to output RPM. Okay, this is the fourth speed. It is shown here if you see. Okay, this is going through, I mean, a straight line. Okay, directly from input to output. So this is the actual manual transmission nowadays, which is used in our vehicles. Okay, now this is the reverse gear. Okay, the idler is connected, so this will cause the reversing of the rotation. So anyway, I hope that you understood the current manual transmission system. Now, apart from this manual transmission, so if you see this manual transmission, this does not require, I mean, too many components, electronic components, you say, or the computer related components. Okay. When we talk about the automatic transmission system, they require additional components. I mean, there will be too many. Nowadays, we have got even the concept of artificial intelligence, because you always require some controlling unit in the automatic transmission. You are not controlling the thing. Okay. So it's intuition based, you can say, that there should be some sensor system. It will sense what is happening in the vehicle. Then there will be some actuation system, and it will actuate accordingly to the system. So that is what our automatic transmission system consists of. Okay. Okay, this is synchronous mechanism. I mean, the same pictures, nothing is different. Okay, the gear selector mechanism, and it will select the gear. Okay, so I will not discuss this part. This is the automatic transmission, although this is one based on the epicyclic gear set. It is shown over here. Okay, and each epicyclic gear set will actually, it is along with one set of clutch also, and there is a torque converter also which is coming into the place. That is the latest concept, okay, based on the hydraulic system. Anyway, just I will start with, okay, I do not have the components, so I will discuss here itself. Okay, The automatic transmission system, if you see, you will listen a lot of name nowadays. And I will say that these automatic transmission system, they employ different mechanism. Okay. I mean, there are too many. If you see nowadays, the one particular name you will be hearing a lot from Kia and Hyundai, that will be the DCT, dual clutch transmission. Okay, in Volkswagen, I mean in German companies, Volkswagen and possibly in Skoda also, this DCT is DCT is what kind of DSG? Both are same actually. Okay, again this entire system is what this DCT and DSG, dual clutch transmission. This is an automatic transmission system. What they are doing, if you see in this dual clutch transmission system, your gearbox will remain same. They are having two set of clutches actually here, clutch system 1 and clutch system 2. Okay, two clutches. In manual transmission we have only one clutch system. So in DCT they will have two set of the clutch systems. So one clutch system, and then again there will be clutch gear, it will be the counter gear, and then there is shaft, and here also you have got shaft. So gears will be engaged, constant mesh whatever is there, it will be engaged. Now the fact is that one set of clutch, it will be connected with 2, 4, 6 gear, and C1, one set of clutch system, it will be connected to gear number 1, 3, 5. So suppose you are running in gear number 3 and you want to move ahead in gear number 4. So it will sense basically, because you will be, this is automatic transmission. So it will sense that you are putting the throttle more, you are increasing the speed. I mean, of course, you are going to put more effort on the accelerator if you are interested in increasing the speed. So it will sense that particular thing, that you are increasing the speed. Now there is always a constant mesh between these gears. So what will happen? Let me say that from 3 if you are going, so for the gear number 3, this C1 will be engaged. Okay, the clutches will be engaged and they will be transmitting the power through gear number 3. Of course, there are two connections. Now, when it senses that you are going to increase the speed to 4, so this 4 will be actually, I mean this gear C2, it will be always connected to 2, 4 and 6. So it will prepare accordingly gear number 4. So the meshing will slowly start at gear number 4. And as you keep on increasing this one, what will happen? Slowly this C1 will be disengaged and C2 will be engaged through gear number 4. Similarly, if you are decreasing the speed, so what you will do? You will, of course, release the accelerator. You will remove your legs from there. So when you are releasing the accelerator, then also it will sense that the throttle speed is going down. So accordingly, when you are in gear number 4, it will move to gear number 3. And since this is automated, it will not bypass anything. It will go from 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. So that particular system will be always there. Okay, so this dual clutch transmission is there. So DCT or DSG. DSG stands for dual shift gearbox. Dual clutch transmission, dual shift gearbox. They are having the same mechanism. But you remember that each and everything is dependent on sensor system. Okay, there must be some sensory system. Okay, which will be able to sense what is going to happen and then actuate accordingly. Okay, another system you will be listening nowadays, that is IMT, intelligent manual transmission. Okay, so in this IMT, just you can say that this is clutchless. Clutchless means what? You don't have clutch pedal. Okay, that's it. The clutch pedal is removed. So definitely it requires a lot of electronic components. So you have got some transmission control unit or electronic control unit. Just I don't remember what is called, TCU or ECU. Okay, ECU, electronic control unit, or transmission control unit, something like that. So it will have then lot of things, and again it will sense whether the speed is increasing or decreasing, because you do not have the clutch, but you have to do the manual transmission. Please remember, you have to put the gear 1 2 3 4 5 6 without the clutch pedal. So as soon as you are putting your hand on the gearbox and you are giving that motion, this transmission control unit is going to sense that what is happening, and based on that sensor, it has the internal system of clutchless, you can say, that engagement system. So accordingly it will start the action and it will help you in transmitting the motion. Okay, so these are the new systems we have got for our this transmission system. And this DCT, IMT, everything, all of them, they are using the constant mesh transmission, the previous one. Okay, the constant mesh gearbox they are using. Okay, now the automatic transmission, this is possibly the older one, where what we have got, we have got multiple epicyclic gear sets, gear set 1 2 3. Okay, so depending on your requirement, depending on your rotational speed, the epicyclic gear sets, they will be engaged with the help of these clutches. Clutches means, in previous one I was calling it as a dog clutch. Okay, so there will be something differently which will try to engage or disengage the thing, and this movement is based on what? The speed of the input shaft and output shaft. Okay, so we'll not be taking too much on the automatic transmission. If you are interested, just you can look about them. Okay, automatic means you do not need to do anything, just you put that this kind of drive you are interested. Okay, reverse, neutral, and forward. I mean, there are a few codes, R and PD kind of thing. So you can act. Just I will show you that how this epicyclic gear set is acting. I will show 1 or 2 slides I do have. Then I will tell you about the torque converter little bit. So this is automatic transmission system with epicyclic gear set. Here if you see, automatic planetary in overdrive. What is happening here? If you see the black color, that is the planet carrier. These gears are the planets. Okay, these are the planets 1 2 3. This one is the ring gear R, and here what you have got, the sun gear. So what is happening when there is overdrive means the highest gear, whatever highest gear you are using, generally that will be called as the overdrive. Okay, maximum speed overdrive. So this overdrive, what is happening? If you see, there is the planetary gears is set. This sun gear is fixed. Okay, if you see here, the sun gear is the stationary member, and this ring gear, this is the output member. And what is the input? The planet carrier. The planetary trains, they are getting the input from the input shaft. This is the way we'll be connecting, because there was a dog clutch. If you see, clutches were there, so they will engage a particular component accordingly. Okay, so this planet gear, this sun gear is fixed. This planet gear will give the rotation to this one sun gear, I mean this ring gear, and it will be transmitted to the the main shaft. If you are interested in reversing the motion, then what you have to do, simply you bring the transmission to, I mean the input to the sun gear. If you are bringing the input to the sun gear, what will happen? This planetary gear set, it will change the direction, because this will act as an idler, you can say. And then the ring gear direction will be changed. Okay, so in the reverse gear, this is going to happen. Now you see here, the input gear is what? The sun is this particular sun gear. Okay, and the output is again the ring gear, and the planetary carrier is fixed. So this carrier is fixed. So what is happening? The planet gears, they are acting as idlers. Okay, the sun gear is rotating. It is creating rotation in the planet gears, which are the planetary gears, which are the idlers, and then it will be transmitted to the ring gear. So that is the way when you are engaging with the help of that dog clutch, it will be transmitted. Now the thing is that the movement of that dog clutch, that is controlled by the torque converter. So that torque converter, it is shown over here. Okay, if you see this box, this is the torque converter. Okay, so actually in torque converter, what is happening, we are I mean, by the name itself you can see that you are multiplying the torque. Okay, and for that purpose, the torque converter has got three components, I will say. The one is turbine, another is pump, of course the centrifugal pump, and in between there is a reactor. Okay, and sometimes it will be possibly called as a stator. Like in the Norton's book, this is called as stator. So this reactor also have got the blades, okay, along its periphery. So what is happening, if you see, this turbine is connected to output shaft and this pump is connected to input shaft. Input shaft is coming from the left side and it is connecting the pump. Please remember that input shaft, if this is the input shaft, so what will happen, it will connect the pump. The pump will be over here. Okay, so this will be directly connected to the pump, and then this turbine will be connected to the output shaft. Okay, so I mean, just you can see that this pump is connected to input shaft. I mean, there is such kind of arrangement that it will be connected, and this turbine is connected to the output shaft. So what happens when there is a centrifugal pump? It will pump the fuel. I mean, there will be the liquid within this one. Okay, so this pump will be always, this centrifugal pump will be always in rotation because it is connected to the input shaft. So when it is always, I mean, when it is always in rotation, it will keep on pumping the fluid. It will pump the fluid to what? The turbine. So basically, it will be pumped. If this is your pump, so from the circumferential part, the fluid will be pumped to what? The turbine. Here you have got the turbine. Okay. So this is actually a high energy fluid from the pump, whatever you are pumping. So it will create a rotation in the turbine. Now the thing is that you are not pumping from outside, rather the fluid is completely sealed within this particular torque converter system. So whatever fluid is coming to this turbine, it has to go back to this centrifugal pump again. So there will be what? A system that will be called as a stator. Again, stator has got the blades. Remember that each blade, whether it's pump, turbine or stator, they are perfectly designed so that whenever it is required, you can create high amount of torque. When not required, when torque is not required, the stator will, I mean, allow the flow of the fluid accordingly. So the pump is transmitting to the turbine. So this turbine will start rotating. And this turbine is connected to what? The output shaft. So it will go to the output shaft. So when you require high amount of torque, accordingly this turbine will be creating that high amount of torque. When you require low torque and high speed, this turbine will create that one. So what is happening from this turbine, based on the requirement? If turbine is stationary, this stator will actually help in creating high amount of torque. So the fluid is flowing this way. Okay, it is coming to turbine, and from stator again it is coming to this centrifugal pump. Now when it is coming through stator to the centrifugal pump, then you have got that multiplier function. So if the turbine is static, it will create, I mean, such a direction that the fluid will be possibly thrown out to the circumference of this pump. I mean, with high energy. So you already have got some additional energy, and then this additional energy will be transmitted to turbine. So that is why we are multiplying the torque. And when you are in motion, this particular direction, it will not come to the periphery, rather it will have some inner portion. So I mean, this stator is basically helping you in creating that kind of conversion. And definitely you remember that this torque stator and this pump, turbine pump, they are close together. And actually in the turbine nowadays, here you will get a clutch system. Clutch means what? It will push the turbine so that it is completely engaged with the pump. So I mean, this entire system is now a clutch, turbine, reactor and pump. And this torque converter is, I mean, nowadays is in use in our automated transmission system. So this actually removes the requirement of that clutch pedal or even the gear shifting, because based on this speed, accordingly here you will be getting the changes in your speed. So this is the torque converter, the purpose of the torque converter. Now another one is this continuously variable transmission. This CVT, this is actually heavily used in Honda cars. If you see Honda automatic cars, we are using this one. The thing is that in this CVT, what we have got a belt, okay, and it is connected to conical pulleys, okay. So there will be some conical pulley. So this is one input, you can say, and then this one, okay. So you have got the actually the belt over here, okay, and this is the conical pulley. So what is happening with the speed? These pulleys are movable. One set of pulley is movable, okay, and this set of pulley is movable, and this is a fixed one, okay. They will not move. So what we are doing actually, when these pulleys, conical pulleys will move inside or outside, they can move outside also, okay, of course, depending on the speed. So you know that in a belt transmission, you can control that speed ratio by changing the diameter. Okay, so this is our one is input shaft, another is output shaft. So when one is moving, I mean when input shaft, if you are changing the diameter of input shaft, the speed will increase. If you are increasing the diameter of input shaft, the speed will increase. If you are decreasing the diameter of input shaft and you are increasing the diameter of this output shaft, the speed will decrease. So actually this is what, based on your throttle, this is the continuous variation, because this belt will keep on moving on this conical pulley. So this is the kind of arrangement you have got here. So based on that, this name comes, the continuously variable transmission. Okay, as far as which system is better, I mean everyone has a different say, so definitely it is better that if you look into the not literature, you can um, go to certain, I mean, good review sites, Autocar or Overdrive, okay, they are very good actually. So there possibly you may get some idea which one is better. Everyone has a different say, everyone has, I mean, different aspect of thinking perspective. So you have got the different systems. Now this last part of our transmission system is the differentiation. If you are moving on a smooth road, there will not be any problem, okay, but when you are moving on a curve, what will happen? You have got the 4 wheels, 1, 2, and then you are connecting it to this one, and you are taking a curve. So the fact is, just if you take the distance from here to here itself, so what is happening, if you see on a curve, this particular length is 2 pi r1 if the radius is r1, and this particular length, it is 2 pi, I mean sorry, it is of course the sector 2 pi r1 over theta, something like that one, and this is 2 pi r2, I mean some particular value based on the angle. I will remove this one. I will write in terms of the angle itself. Okay, so this radius is r2. Let me say this one is r2 from here to here, and r1 is from here to here, and definitely the angle is a constant one. So this one will be r1 theta, this one will be r2 theta. So the fact is that the inner wheels, they are moving less amount of distance. Outer wheels, they have to move larger amount of different distance. So the fact is, and the velocity is what? You are keeping the velocity as v. So the velocity remains same actually for the vehicle. You are not going to change that. So this is a tough task. So what will happen? There will be a sliding kind of thing, so that this inner wheel I mean it will try to move the same amount of distance. So you can say there will be a sliding, or you can say that it will be dragged. Okay, so definitely that is not a good scenario for our vehicle. You will always get the turns. So for that purpose, we have got the differentiation unit. The differentiation unit, here it is shown 3 differential unit. This is your rear wheel, this is your front wheel, and here you may have the gear system, I mean your engine system somewhere over here. Okay, in this part. Now what is shown here, this is the all wheel drive actually. If you have a rear wheel drive, then you require one differential over here. That's it for the rear wheel drive. If you have got a front wheel drive, then of course you require the differential over here. That will be enough, because you have to differentiate the motion in the particular wheel set where you are supplying the power. Now if you have all wheel drive, AWD, or 4-wheel drive, जो महिंद्रा थार आई है ना, that is a 4-wheel drive. Generally it is used in I mean that kind of, you can say, the sport utility vehicles. They, out of them only, they have the 4-wheel drives. Mahindra Thar aaya hai abhi. You have got some other vehicles. Okay, so this 4-wheel drive is there. So there you have got front, I mean because all the wheels are driven, so you will have one differentiation on rear, one on front, another will be central one. And actually the central will supply what is the requirement at the front and rear. And when it is coming to the rear, this differentiation unit will transmit accordingly. Okay, this will transmit. So that is the fact that this central differential unit, it will 50-50 is required or 40-60 is required. This will be decided by the central differential unit. And then when it is coming to the rear differential and front, then these differentials will decide where 25-25 is required or 20-30 is required. This will be decided at this rear differentiation unit. Okay, so just I will let you know one small concept before ending the class. What is happening, if you see, our input is coming from this side, okay, from here, and then you have got a pinion. Okay, you have got a pinion. This pinion will be attached to a large gear, you can say the ring gear. Okay, and actually this ring gear is something that there will be one spider gear also. I mean, if you see, there will be one spider gear, that is called as spider gear. And actually that spider gear is creating that differentiation. So the fact is that this spider gear will be attached to this shaft. So this spider gear will keep on rotating along with this shaft. Okay, as your shaft is rotating, this spider gear will rotate. Apart from that, this spider gear is connected to one particular ring gear, this larger gear. Okay, so what is happening that this ring gear can have the rotation as well. इसमें नहीं है, अच्छा अच्छा तो नहीं दिखाया है, यही वाला है, ठीक है. So the basic thing is that this ring gear, when you are running on a straight line, this spider gear will be static. Actually, it will not have, of course it will rotate along the shaft, but it will not rotate on its axis. So there are actually two motions with this particular gear. This is our spider gear. So one is that it is rotating along with this axle, okay, this shaft. Another is that it is rotating along with, I mean, on its axis also. Okay, this is the axis. So this axis is vertical, you can say, and it will keep on changing. So there are two motions for this spider gear. The one is along with this shaft, and another one is on its own axis. So when you are moving in a straight line, this axis movement, this is not happening. So it will only have a rotation. So it is not going to affect anything. But when there is a turn, what happens? This spider gear will start rotation because it will be attached to the ring gear. So based on this wheel's input or output, it will have the motion. So actually on one side, what will happen? This velocity and this velocity will be added together. The shaft velocity and this velocity. This will be added. So it will be V1 plus V2. And on the outer wheel, what will be happening? It will be actually opposite. If you observe, it will be opposite. So it will be kind of V1 minus V2. So the inner one, it will be getting the V1 plus V2, and the outer one, it will be getting V1 minus V2. So the transmission will be what? This one will have, I mean, I'm sorry, the outer one will be getting the V1 plus V2, and the inner one will be getting V1 minus V2. So the speed reduction we are able to perform. Okay, so based on this aspect only, we are able to differentiate the speed. Although there are other issues, so nowadays we have LSD, limited slip differentials. Okay, because sometimes if you have got a road where one is on dry, one wheel on dry, another one is on wet surface, then also this differential will start working, because this spider gear, it is actually completely based on the output requirement. Okay, so it will transmit actually more torque on this wet wheel. More torque means you are going to get the skidding, sliding. So that is somehow, I mean, blocked in this limited slip differential. Another is nowadays used, although I have not seen its function, I mean how it works. That is the torsion differential that is in use nowadays. But yet I have to see how it is working, that torsion.